This is review from last year, but I just want to mention, remember when we looked at a function f of x and we wanted to find the area from A to B? What did you do to find this area? You went the area from 0 to b of f of x dx, and then you did what? 0 to a of f of x dx, and then did you add them or you subtracted them? The reason you subtracted them is because 0 to b f of x dx plus, you could reverse these, a to 0 f of x dx. There's a property that says if you go from a to 0 and then 0 to b, it's just the same as going from a to b, f of x dx. Now tell me about these rectangles, though, that are in here. They're infinitely thin. What's the width of them? In my equation here, f of x dx from a to b, what's the width? Dx. This is your width. What's your height? The height is f of x. So essentially what you're doing is this is going to be your height. Essentially what you're doing is you're accumulating all of the rectangles from left to right, from A to B, width times height. Okay? So with that in mind, you kind of can see where this is going to come from. A rotational volume is taking an individual rectangle and spinning it around, in this case, the x-axis. And when you spin it around the x-axis, what shape does it make? Not cookie, but you're close. It's a perfect cylinder is what it is. And what's the volume of a cylinder? Yep, it's pi r squared, the base, times the what? Times the height, right? Or the width, or whatever you want to call it. So what is the width of this little cylinder? That's dx. What's the radius of this thing? The height, f of x, and it's squared. And then what do we have to multiply out in front? Pi. Pi r squared times height. And that is from A to B. That's going to be your disk method. And likewise, when we went the big minus the 0 to b minus 0 to a, we're going to do something similar when we have two functions. If we take this one up here, which is going to f of x, you're going to have pi a to b of f of x squared dx. But then you're going to take this one down here, going from a to b, and you're going to find that volume, pi a to b of g of x squared. And what are you going to do with this one here rotated around compared to this big one up here rotated around? You're going to subtract them, right? So when you subtract those two, we can put them together into one grand formula, the disk formula, which is pi going from A to B of the first one, f of x squared, minus g of x squared. And what do you think is the number one thing people do wrong in these? What do you think they do first? Turn to your neighbor. Tell them what's the number one thing they do wrong with that. They subtract first and then square. And that's not the same thing. Well, think of this. 5 squared minus 2 squared. Let's just take those two numbers. Is that the same as 5 minus 2 squared? 25 minus 4 versus 9. I mean, that's the simple way to explain it, but visually you could see that too. So this is kind of blobby. Let me just give you the formula one more time. For the disk method, it's a to b f of x squared dx. For the washer, it's the same thing, but what do you do before you subtract? Thank you. Square first, then subtract. Square first, then subtract. I cannot tell you how many times people do it the other way. I don't know why. Just don't. It's a mystery. Okay, shell method, don't worry about that. For examples, I'm going to have you look at these examples. These are review. And for the assignment, I want you to go to skip Gabriel's horn. Do 10A, E, E, and 11, and 15. That should be it. Don't do these. That's too much. So just go to 15. Stop. And we'll work on these, get some interesting integrals to contend with.